In our study of the graphs of the sine and cosine functions, we've looked at the base graphs, sine of x and cosine of x. We looked at amplitudes, we looked at periods, and we did that separately. And in this video, we're going to look at the amplitudes and the periods of the sine and cosine graphs. Our objective: given a function of the form y equals a times the sine of bx, or y equals a times the cosine of bx, we want to find the amplitude and period, and we want to sketch the graph. And we're going to make use of Desmos as well to see what we come up with. Okay, so what do we know coming in that's going to be useful here? Well, the graphs of y equals a sine of bx and y equals a cosine of bx are sinusoidal. They are periodic or cyclical. They have amplitudes that are equal to the absolute value of a. They are inverted about the center line if a is negative, which means the sine function, instead of starting up from the origin, will start down. And the cosine function, instead of starting down from 1, will start up from -1. They have periods equal to 2 pi over b, and they have 5 key points within each period. The key points are zeros, maximums, and minimums. Okay, now to find these key points, we saw this briefly in a previous video, we take the period and we divide it by 4. And that will give us the distance between these key points. So we're going to see that coming up right here in this first example. So let's take a look. Okay, example number 1 here. We want to sketch the graph of y equals 3 times the sine of 4x for x's between 0 and pi. Now let's take a look at how that's going to work. Okay, so we want to go all the way from 0 to pi in this one. Well, let's first come up with the amplitude. The amplitude is equal to the absolute value of a. In our case, a is 3, so it's the absolute value of 3. The absolute value of 3 is positive 3. Now, this a is not negative, so we don't have to worry about inverting it about the center line when we start. It's the sine function, so we'll start at the origin and we'll go up as normal. Okay, so what's the period? The period is equal to 2 pi over b. Okay, b is 4. So the period equals 2 pi over 4, which is equal to pi over 2. So we can draw, in this function, we can draw one full period in a distance of pi over 2, which means if we're going to go from 0 to pi, we're going to draw 2 full periods, because pi over 2 is only halfway to pi. So we can see here we're going to be drawing 2 full periods of this sine function. Now let's take a look at the distance between the key points. If we take the period and divide it by 4, well, the period is pi over 2. I'm going to divide that by 4. Well, that's the same as pi over 2 divided by 4 is the same as pi over 2 times 4 over 1. Whoops, take that back, excuse me. Pi over 2 divided by 4 is the same as pi over 2 times 1/4. And so the distance between key points. Okay, this is the distance between key points. And this makes it kind of easy to do our sketch of our graph. Okay, so let's take a look here. I'm going to do one period in here because I have 1, 2, 3, 4, 5 slots for the key points. We know that when x is 0, pop it in here. The sine of 0 is 0. 3 times 0 is 0. Y is 0. Now the distance between the key points is pi over 8. Okay, this is pi over 8. Okay, and we put pi over 8 into this function. Okay, we're going to come up with 3. Okay, again, you can put that into here and you'll get 3. Now remember, we're using pi, so make sure you're in radian mode. Let's go another pi over 8. 2 pi over 8 is the same as pi over 4. This is 2 pi over 8, which is pi over 4. Put pi over 4 in here and do the calculations, and you get 0. Let's go pi over 8 again. This will be, whoops, there is no simplification of that. This next key point will be 3 pi over 8, and we'll come up with negative 3 in the calculator. I go pi over 8 again, so this is going to be 4 pi over 8, which is the same as pi over 2, and that's a full period. We have it right here. We got to pi over 2, and we're going to go back to 0 if I put 0 into this function. Okay, so this is 1 period's worth of points. Okay, now we know the amplitude is 3. I'm going to go ahead and I'm just going to go ahead and go 1 inch above and below, and we'll call this 3 and negative 3. And because I need to make 2 full periods, again the period is pi over 2, and I need to go between 0 and pi, I'll mark them every 1/4 inch in my case. Okay, so let's start. This will be 0, obviously. This will be pi over 8. This will be pi over 4, which is 2 pi over 8. 3 pi over 8, 4 pi over 8. That's 1 full period. Let's do that first. At 0, we have 0. Okay, our amplitude is 3. It is not a negative, so we're going to go right up to 3. And pardon my drawing, there's the key point. It's a maximum. And then at pi over 4, the sine function comes back to 0. And then at 3 pi over 8, we're going to go down to negative 3. And then at pi over 2, we're going to go back to 0. So this is the sine function. This is 1 period of this sine function. Let's continue. I'll go back up here. I'll come back down here. I'll come back to here. And this is pi. Again, this is 4 pi. This is 5 pi over 8. This is 6 pi over 8, which is 3 pi over 4. This is 7 pi over 8, and there's 8 pi over 8, which is pi. So there you have it. There's the graph of that. Let's take a look at that in Desmos. Okay, so I'm going to pull this off. Okay, let's get Desmos in here for you with my graph. I think I got that straightened out. Okay, so in the top here, I'm going to put the graph in. I have y is equal to, this says 3 times the sine, that's a function. So go into functions and select sine of 4 times x, and I'll close parentheses. Here it is. Okay, you can see, as mine came up, the key points are already highlighted by Desmos, and that's 1 full period. You know, 1 full period goes from same spot to same spot. So it went from 0, 0 to pi over 2, 0, up to pi over 8, comma 3, back to pi over 4, so another 0, down to 3 pi over 8, negative 3, back to pi over 2, and then the second full period goes to 0 here. So 1 full period to here, 2 full periods to here, and because I'm in radian mode, it gives me the minimums and maximums and the zeros using the pi terminology as opposed to approximations. Okay, let's do another one. Very nice. Okay, let me get my notes together here. Just a second. Whoops, wrong place. Okay, let's get my paper straightened out. All right, sketch 1 period of the graph of y equals negative 8 cosine of pi x over 4. So in this case, my b is pi over 4. Notice that my a is negative. So this is the cosine function starting from below the x-axis and coming up because of the negative here. Okay, so amplitude, which I'm abbreviating AMP. The absolute value of A, the absolute value of -8. The amplitude is 8. Amplitude, high point minus low point divided by 2. Okay, I have a negative sign in front. Let's know that. Negative sign in front tells me that I need to invert the starting point. Normally the cosine function starts above the x-axis at 1, which in this case would be 8. In this case we're going to start at -8 and start up because of the negative there. Okay, the period is equal to 2 pi over b. Okay, b is pi over 4. So 2 pi, big fraction bar, divided by pi over 4. That's a complex fraction. So let's simplify that. This is 2 pi over 1 times the reciprocal, which is 4 over pi, which means my period is 8. Okay, now let's take that period divided by 4. 8 divided by 4 is equal to 2. And this, as we know, is the distance between key points, because we're divided into 4 equal regions, if you will. Okay, so now let's graph it. Okay, so I'm going to make a I just need to draw one period, I think. Yep, just do one period. So again, I'll go back and I'll just just a little bit of accuracy. I'll do the 1 inch thing again. So here and here, and this will be 8 because my amplitude is 8 and -8. Okay, and I need to go 8 units. I'll tell you what, let's do every ½ inch. It'll be a little bit small for my graph. 1, 2, that's fine. Then we'll go to right there. Okay, so I'm at 0. The distance between is 2, so I'll go 2 plus 2 is 4, plus 2 is 6, plus 2 is 8. So there's, and don't forget 0. Here's my 5 key points and my 4 spaces between them, my 4 distances between them. Okay, it's negative, so I'm going to start down here with the cosine function because it's negative, and the cosine goes up through the 2. It maxes at 4. It goes down through the 6, and it minimizes at -8, and that is 1 period of this graph of the cosine function. Let's remind ourselves amplitude, highest minus lowest divided by 2. 8 minus -8 is 16, divided by 2, amplitude is 8. Let's see it in Desmos. Always nice to see things a little neater than I can draw. How about that? Okay, so back to here. Our function is y equals, and we had a -8. Go into functions and choose cosine, and it said pi times x. Well, here's the pi down the bottom of this little mini keyboard. Let me go back first and put a fraction bar in there. Okay, pi times x over 4. Okay, there it is. Let's do a little shrinking. We're looking for 1 period. Okay, so here's the 1 period. Starting on the y-axis, at the bottom, 1 period means go to the next bottom. And so up and then down. And if you want, we can highlight these points. That's the point 0, -8, the point 20, the point 48, the point 60, and the point 8, -8. And that matches up beautifully with the graph that we drew. And again, we just wanted to get 1 period in there. And so from here to here is 1 period of this cosine function. Okay, let's do another example. This time we're going to not worry about the graph, although I'll show you the graph. Find the function of the form y equals -2 times the sine of b times x that passes through the point pi over 4, that's the x coordinate, and -2, which is the y-coordinate, and for which b has the smallest possible positive value. So we got to find what b is. Well, fortunately, I mean, here's the equation. Y is equal to -2 times the sine of b times x. Well, I know an x and a y that work. So I can put x in for x and y in for y, and then solve for b. So y is -2 equals -2 times the sine of b times x. Well, x is pi over 4 times b. I got to solve this for b. Well, let's first divide both sides by -2, and that gives me 1 is equal to the sine of pi over 4 times b. Now I need to get inside this sine function, so I'll take the inverse sine of both sides. So I'll inverse sine the left, and I'll inverse sine the right to undo the sine. The left side is the inverse sine of 1. I think that's I think that actually you can probably solve that, but I'll leave it like that for right now. And on the right side, I have a pi over 4 times b. Again, we can put this in a calculator. I'm going to leave that for the last step. And we have this, and I need to get b by itself, so I will multiply both sides by the reciprocal. So times 4 over pi times 4 over pi, and I get b is equal to 4 over pi times the inverse sine of 1, and we're in radians. And I believe the inverse sine of 1, I think, is pi over 2. I think it's pi over 2. Yes, this is pi over 2. So b is equal to 2. Putting this into a calculator. This is a calculation. Okay? So now that I know the b, I can come up with the function here. This leaves me with the function y is equal to -2 times the sine. Well, b is 2. How about 2x? Let's check it. We want to see if this point is on this graph. Okay, let's go to Desmos. All right, let's go out of this one. And let's see. So the equation, the function I found, or the equation I found, -2 times the sine of 2x. Oh, I forgot to put a equal sign in there. I wonder why I wasn't getting a graph. There we go. Here it is. So that's our function. And now let's see if we can find the point pi over 4 comma -2. There you go. Right there it is. Pi over 4 comma -2 is on the graph. Okay. Pi over 4 is a little less than 1. That's why I chose that point right there. And of course, -2 would be one of these along the bottom. So there you have it. Pi over 4 comma -2. Okay, the last problem we're going to look at. We want to, let me get my notes so I don't make any mistakes. I don't want to make too bad of mistakes here. We want to rewrite the function with a positive angle and then graph the resulting function. Well, this currently has a negative angle because of the -2. So we need to recall, go back into some of your earlier trig days, that the sine of the opposite of x is equal to the opposite of the sine of x. A little factoid you need to remember. Okay, so y equals the sine of -2x, which is right here, can be rewritten with a positive angle by moving the negative in front. Y equals negative, whoops, not negative. Oops, I forgot something. I forgot the 3. Let me go back, and I was wondering why my notes look differently than my paper here. Okay, so we recall this, but I forgot the 3. So y equals 3 times the sine. I bet you were way ahead of me on that one, thinking, Coleman, what are you doing? Okay, so let's move the negative to in front. And so this is the same as y equals -3 times the sine of 2x. Okay? So we can graph this. Okay? We know the amplitude is equal to the absolute value of a, which is the absolute value of negative 3, which is 3. We know there's a negative in front, so negative sign in front tells us we need to invert. So we're dealing with the sine function. So instead of starting at the origin and going up, we'll start at the origin and go down. Okay, we know the period is equal to 2 pi over b. Okay, what is b? b is 2. So 2 pi over 2, which equals pi. And we know that the period divided by 4, here's the period, pi divided by 4. This is the distance between the key points. Okay, and we have 5 key points we know about. Let's take a look. Okay, so we want to graph this. Okay, so there's the y-axis, here's an x-axis. I'm only going to graph one period. Again, I'll go back to here and I'll use the 1-inch mark to try to keep my graph a little bit more accurate. Because we know the amplitude is 3, I know I'm going 3 to negative 3. Okay, so the period is pi, and I know that I'm going to go pi over 4 to get from key point to key point. So let's see here. I'll again go by 1/2 inches just because I didn't make my line long enough. So there's my 1 period. I know the period is pi units long, so this is pi over 4. 2 pi over 4 is pi over 2. This is 3 pi over 4. So there's my sine function, 1 period from 0 to 0. Again, I've got a negative, so I'm going to invert, start here, go down to a minimum, come back to the 0 at pi over 2, go up to the maximum of 3, and then go down back to 0. And so here is the sine function. Here is this function. Let's see, this is the function 3 sine of negative 2x. Now, I'll let you do this. Put this function into Desmos, and you should come up with 0, 0, pi over 4, negative 3, pi over 2, 0, 3 pi over 4, 3, and pi 0 when you pick those points. So there you have it. A lot of work with sine and cosine, amplitude, and period.